Okay, so our full output and minimum output are the two tests for demand response. Each of them has a before, in your case before pushing the button, and after demand response readings. In our case we had 1, 2, 3, 4, 5 areas in a building called Building 6. The unfortunate Building 6, as you guys discovered, because the people who put the demand response in and or programmed it didn't do a very good job. Each of these things has an area. Your 5 areas in Building 1, and then you've got your area of Building 6. This is all your power reduction test. Okay? And we're actually, this is a good way to lay this out because you're going to need to do your percent reduction. Hold on. That's what should actually be here. Percent reduction. Because this is a power reduction test. And then your area. And then I'm going to run out of board. So we will just save the minimum output side of the test for a couple of minutes from now. And what you're going to do is you get your before and after readings, you calculate your percent reduction for each of these areas, and then you're going to multiply each of those percent reductions by the area of the areas, and this is going to give you all the terms in the top of that crazy looking equation. You're also going to need the sum of the areas, so you're going to need to add all those up as well. And then you're going to get all those top terms in the equation, and then you're going to sum all those up, and those are going to be the top of your area weighted average formula. And then you're going to divide that by that. And thankfully the automated form does it all for you. So, good. Who's got good numbers? Who you got it? You, sir. Hit me.
So we have 53.4.
53.4.
The after is 38.
Okay.
2. You want to drop to the second one?
Sure. Let's go do the
45.
How much?
45.
45.
And 42.4.
42.4.
53.8.
53.8. Oh, these are looking like good numbers.
And 38.1.
38.1.
53.2.
53.2.
38.
And 38.
32.6.
32.6.
29.
Oh, and 0.9. The last one. That's... No.
There's one more.
Sorry. Down here for area 6, you got what now?
Area 6, we have 45.3 and 12.
Oh, I'm sorry, 45.3
and I have 12.1.
12. Well, what did I miss up here on 5?
32.6 and 29.
Oh, 29. I'm sorry, I misheard. Okay, so those look like pretty good numbers. Did you calculate the percent reductions on these?
Yes.
Okay, just spit them on out. Area 1.
28%.
That sounds just right.
6%.
Very good.
29%.
Very good.
29%.
Very good.
And 11%.
And 11%. Okay, that sounds good. 73%. Okay, so what do we know about Building 6 right away?
It's a fail.
It's a fail because we dropped below 50% of our full output illumination during demand response. And the CEC says that's making it too dark. so everybody's got a little surprise coming that they got different absolute numbers, but did anybody get anything really different? For those of you who've already done the percent reduction, you should see that these are all pretty close. If you line up all these light meters on a table, they're all going to read somewhat different. You can send them all out to calibration labs, get them all back, and put them back out on the table, and they're all going to read something different. Okay, so make sure your light meter's working. iPhone apps not allowed, or I'm sorry, smartphone apps not allowed. You want to use a registered trademark there.
You can edit it out.
Okay. All right, oh, the areas. What do we got there? 1,200?
1,200,
Okay.
then 800,
Okay, hold on. 1,200, 800,
5,000,
5,000,
3,000,
3,000,
1,000.
1,000, and of course, the unfortunate building 6, I think is like 1,200 or something. 12,000. That's why required demand response, buildings over 10,000 square feet, and don't ask me what a building is. All right, so I'm just going to multiply, we're just going to do it as a percentage basis. So it's 28 times 1,200 equals 333,600. Yikes, you're going to get big numbers. And I kind of suggest doing it term by term like this so you don't get messed up trying to do these big calculations. Because if you can do it all in one shot if you really, really feel like it, using the parentheses and whatnot on your calculator, but that makes it a lot easier to mess it up. So I got 145,000. Yikes. Is that too big? No. So the next one should be about the same. Oh, no, not about the same. About 3/5 of that. Okay. And it should be 11,000, right? And now, I'm going to use this special little symbol they use to show you're summing things up, called epsilon. Something like that. And we're just going to sum all these numbers up, because the bottom of your area weighted average formula is the sum of all the areas. So we'll just sum these up. 11,000 plus 87,000 plus 145,000 plus 4,800 plus 33,600, and this all equals 281,400. That is our numerator. That's our denominator. That's the bottom of the fraction for the area weighted formula. Now I'm just going to, this is the numerator. It's the top, right?
Yes.
Yes, this is the top of your formula, okay? Divided by the sum of the areas. So let me sum up the sum of the areas. It ends up kind of backwards here when you do this. It confused me.
That's easy.
I got 11,000. Sounds about right. So 11,000. All right. So our total area weighted average is going to be this humongous number, 281,400, divided by the sum of the areas, which is 11,000. So let's just do that. 281,400
divided by 11,000 equals approximately 25.6% illumination reduction. Kind of ran out of board there. That's a bunch of math. All right, and that is a pass because it is more than 15% for the sum of all the areas you have tested. Look at some of these areas are small and have very small illumination reductions. Those might be small. That might be the, I don't know, I think the VP's office. We'll say that's the VP's office, Vice President's office, and it's 1,000 square feet. And he doesn't want it to get dim in there in the middle of June, in the middle of the afternoon, so he says, don't turn my office down so much. You'll note that not all of these are below 15% reduction, but when you use the area-weighted average formula, you get over 15% reduction overall. Had you been sampling areas in this building and you did this and you didn't get your 15% reduction, guess what? Sample more areas. Sample more areas to sample the whole thing, and then you can finally go and honestly say, your building failed. Your building failed. Okay, so we know building 6 was out of it in the first place. I'm going to leave these original numbers up, and we're just going to go straight to the minimum output test. And this is not a power reduction test, so we don't care about the percent reduction. We don't care about the area. What we care about is what do the lights do during the minimum output test. In other words, are we going to plunge people into darkness when they already have the lights turned down? So, we have an area 1 before and after, we have area 2 before and after, 3 before and after, 4 before and after, 5 before and after, and of course, the unfortunate building 6. So, same numbers from the same gentleman. Why don't you hit me with some numbers?
41.5.
Okay, that's for area 1.
Yeah, and the after is 39.9.
Okay, that's an interesting one.
And 16.
Okay,
And 16.
very good.
And 10.8 and 10.8.
Very good.
7.6, 7.6.
Okay.
13.2, 13.2.
Okay.
10.7 and 0.
10.7 and lights went out. Sneaking suspicion that if a demand response system puts the lights out in a building or area, that's a fail. You can check those arrows and stuff if you get mixed up. I believe that some of them look kind of screwy, but that's the way they wrote the code. Let's look at the first one in particular. When we turn sliders down, dimmers down, scene controllers down to minimum without putting the lights out, without putting any lighting out, just bringing it down to minimum, we didn't drop below 50% of full output, did we? No. I'm not going to argue with that. I'm not a lighting designer, okay? For our purposes of acceptance testing, okay, fine. This is the minimum. All they say is put the sliders down, dimmers down, whatnot. And if you're not already below 50%, you shouldn't drop below 50%. Well, we dropped to 40. 40 is not below half of 53. That's a pass. That's a pass. The rest of these function perfectly. They were turned way down from their original values, way below 50% in most cases, right? And you initiated a demand response, so they didn't drop any further. So those are all good. Those are all passes. Then, of course, building 6, lights went out. Fail, fail. And those are all numbers came off your test stand. You took them with your own light meters, so now you should feel all comfy and cozy with a little exception of, I'm not going to be able to tell you how to get a demand response in your building. You're going to have to work that out with whoever put in your system, contractors, system integrators, whatever. Okay?